Next up is prime factorization. So prime factorization is when a number is written as a product of all of its prime factors. So we're going to use factor trees to find these prime factorizations, and we're going to write them in exponent form. So to do this, we just simply take our numbers and say, okay, give me two numbers that multiply to make 180. Well, I'm going to take the easy ones of 18 and 10. It's a number that ends in 0, so I know it divides by 10. Now, are either 18 or 10 prime? No. So break them down. 18, the first two numbers that pop in my mind are 9 and 2. And for 10, the first numbers that pop in my mind are 5 and 2. Now, 2, 5, and 2 are all prime. So I'm going to stop those ones there. But 9 we got to break down even further, because 9 can be made into 3 and 3. Now 3 we can't break down any farther. So there's my factor tree. I can't break these highlighted numbers down any further. So exponent form. What's the smallest highlighted number? 2. And how many are there? 2. So that's 2. Whoopsies, I didn't want my highlighter. I want my pencil back. That's 2 squared. 2 2s. Times. What's the next smallest number? 3. How many of them are there? 2, so that's 3 squared. Times, well, the only thing left is the 5 that's by itself. There's exponent form. 2 squared times 3 squared times 5. And yes, I want it in order from least to greatest. If you don't put it in order from least to greatest, I'm going to take at least a half point away. 72. How about 9 times 8? That's the obvious one. Neither one of those is prime. So 9 breaks into 3 times 3. 8 breaks into 4 times 2. Here, on this level, we've got some prime numbers. The 3s are prime, and the 2 is prime. 4 breaks down into 2 more 2s. So there are only 2 different prime factors here, a 2 and a 3. There are how many 2s, since it's smaller? 1, 2, there are 3 of those, so that's going to be 2 to the 3rd power, because there's 3 of them. And there are again 2 3s, so that is 3 squared. 24, well, that's going to be 12 times 2. 2 is prime. Also, these are not the only way to do these factor trees, but we should wind up with the same prime factorization no matter what. 12 is 6 times 2. And 6 is 3 times 2. And both of those are prime. So again, we only have 2s and 3s. There are 3 2s, so that's 2 to the 3rd power. There's 1 3, so just times 3. And last, 13 is prime. We can't break it down. So you can either say prime, or you could just write 13.